So here in section 3, we're going to consider loan and annuity payments. And annuity is just a savings vehicle that will pay you an income, usually in retirement, usually a lifetime income, sometimes for a fixed period of time. So what we're going to do is we're going to derive payments for a loan and then loan amount. So these payments are called present value of future payments because with a loan you get the money now, but then you pay it back in the future. So this PV, that's the loan amount, and it's the payment times 1 minus 1 plus r to the negative n over r. Again, r is APR divided by m. And then if you take this formula and you solve it for the p here, just do algebra, multiply by the reciprocal of this on both sides, you get this formula. So how do we get those? Well, the future value of a single amount, that formula is right here. And then the future value with regular payments, that's this formula here. And so what we do is we take those two formulas and we set them equal to each other. So again, this one was PV 1 plus R to the N. So now we're concentrating on setting these guys equal to each other. And then if we solve that for PV, so we're going to divide both sides by this quantity. So divided on the left, you just got the PV, and then divided on the right. So it's going to come down here. That's this expression right here. And if you want to divide by 1 plus r, what you can do is you can multiply by 1 plus r to the negative n. I'm sorry, divided by 1 plus r to the n, you can multiply by 1 plus r to the negative n. So I can take this quantity and bring it up on top as a negative exponent, and then multiply that by the 1 plus r to the n plus 1. So when you multiply this n times the 1 plus r to the n, they're same base. So n and negative n, you add exponents, and that gives you 0 power, which is this 1. And then 1 plus r to the negative n times that negative 1 is negative 1 plus r to the n. And then you've just got your r down on the bottom here and p out in front. So that's the algebra that's going on there. And then if you solve this for p, again, multiply both sides by the reciprocal of this quantity, that's this formula. So you always want to look and see what are they asking for in the question. They ask for the loan amount, that's PV. If they ask for the payment, that's P. So most of the time, these formulas are used to find the payment on a loan, and then also the amount of the loan, the present value. So those are the use of those two formulas. If you want the interest paid on a loan, you take the total of your payments, so number of payments times payment, and subtract off the loan amount, because the total of payments includes the loan amount paid back plus interest. So let's work on an example. We'll see how this works. So we want to determine the monthly payment. So we want the payment. So P is our question mark, and it's a 30-year mortgage. So that means that our N right here is going to be 30 times 12, which is 360. And it's a $389,000 mortgage. That is your loan amount. So 389,000. And actually my son just bought a house out in California, and it was approximately this price, and this is approximately his interest rate. So I'm using real life example here. These are monthly payments, so M here is 12. And then the 4.25%, that's your APR. So R is going to be, R is going to be 0.0425 divided by 12. Let's see if that is a nice number. Nope, repeating decimal. We'll just leave it as 0.0425 divided by 12. So here's the formula we want to solve for, because it's asking for what's the payment. So that is this formula here, second one, P equals. And so in the numerator here, we want our PV, which is the 389,000. And then R is our 0.0425 divided by 12. And then we've also got that down here, 0.0425 and divide by 12. And then negative n power right there is going to be negative 360. And if we compute this, we get 1913, I guess that's 65 rounded to the nearest penny. So a little over $1,900 a month in a house payment. That's quite a hefty house payment, and that's at a low interest rate. So there are parts of California where $1 million houses are fixer-uppers, or they're teardowns. They just buy it for the land, which sounds kind of crazy because you can get a really nice house around here for $1 million. So how much was paid in interest on this loan? Well, you take the total of your payments, which is 360 payments times 1913.65, and then you're going to subtract off your loan amount of 389. And I need to put this in math mode so I can compute with it. Okay, and if we compute that, 299,914 and 0 cents. So $299,000 in interest. So the house cost $389,000. We paid almost $300,000 in interest. We almost paid for this house twice, which is a little crazy. And the reason is because it's a very long period of time, 30-year mortgage, and you got exponential growth working against you instead of for you. So this is realistic. So trying to get some money sense on a 30-year mortgage, you usually end up paying for your house twice.